Large language models like ChatGPT can answer almost any kind of question. However, when it comes to providing authoritative answers with sources, these models sometimes hit a snag. This is because their responses are based on their training data, which isn't drawn from real-time sources. Moreover, their training data isn't always up to date. So what's the solution to this problem? Enter an excellent technique known as Retrieval-Augmented Generation, or RAG. Let's understand what RAG is, how it works, and what it can be used for. Hello, I am Sandeep Iyer, your AI guru. Retrieval-Augmented Generation, or RAG, is a technique that enhances generative AI models by fetching facts from external sources, making them more accurate and reliable. Essentially, it fixes the issues of accuracy and reliability in LLMs. While LLMs can quickly respond to general prompts, RAG becomes particularly useful when generating content on current or more specific topics. RAG was developed by a team of 12 led by Patrick Lewis, who coined the name RAG. Lewis and his 11 colleagues created this to link generative AI services with external resources, especially those loaded with the latest technical details. In 2020, Lewis and his colleagues wrote a paper describing RAG as a general-purpose fine-tuning recipe, because it allows almost any LLM to connect with particularly any external resources. RAG gives AI models the ability to cite sources like footnotes in a research paper, allowing users to verify any claim themselves. This builds trust in the models. A great example is Perplexity AI, an answer machine type model. It's a combination of RAG and LLMs where users can ask anything and the model provides answers with sources which can then be cross-checked. This technique significantly reduces the chances of LLMs making incorrect guesses since the model already has the proper context through a source, leading to much less hallucination. Another major advantage of RAG is that it is relatively easy to implement. Lewis and 3 other co-authors of the original paper mentioned in a blog that developers can implement this process in just 5 lines of code. This makes the method faster and less expensive than the fine-tuning. Users can also hot swap new sources on the go. Hot swapping means changing the models or sources without turning off the system. So how does RAG work? First, it gathers data from databases, documents, websites, or APIs and then splits into small chunks which are converted into vector representations. These vector embeddings are then stored in a specialized vector database ready to retrieve relevant information based on a user's query when needed. When user submits a query, it is also converted into a vector embedding. This query embedding is then compared with a vector database and the most relevant chunks are retrieved to merge with the original query to create an augmented context. This augmented context is then fed into a LLM model like GPT-4 or Claude 3, which uses this context to generate a natural language response. The final output from the model is a relevant and information-rich answer to the user's query. RAG can be used with LLMs or independently. Using it with LLMs produces more fluent and context-rich responses as it enhances the capabilities by providing them with relevant and up-to-date information from external sources. With RAG, you can practically interact with any data collection, opening up many new possibilities. For example, a generative AI model supplemented with a medical index could be a highly useful assistant for doctors or nurses in hospital. The same concept could be applied for financial analysts linked to market data. In essence, this technique allows any business to convert its technical or policy manuals, videos, or logs into any knowledge bases. I hope this video has given you a clear understanding of what RAG is. But if you have any questions, feel free to ask in the comments. And do let me know what you think about this technique and what other applications it might have. Keep learning. Until next time.